Hello Internet! Today I'm far away because I've got something amazing. Well, not really, but it's big. So today we have Opel Astra L LED headlight. This is Opel Intellilux pixel headlight. As you can see, it's crashed. So we will take it apart and see what's inside. This is a modern lamp, so it's cursed, and it is as cursed as it gets. The only way to interface it is through this plug. You've got 4 pins, 2 for power and 2 for CAN communication. And that's all. Everything is done by this module, which was sold separately by scrapyard. And we're also missing turn signal and daylight running lamps module. Because if they can unscrew it on scrapyard, they will sell it separately. The daylight module is nothing special, it's a bunch of LEDs. I will try to splice an image for you. But you basically got something that lights the side marker and also turns orange for turn signal. And that's all. Got your light guide here, and it's split to the bar and the piece at the side here. So what can we say about the modules inside? Stellantis claims it has 84 light segments. I don't think this is the high beam projection system. I think they count for all LEDs. We got the low beams, which are pretty standard. You can see when you take a closer look inside the lens, you can see they use an array with total internal reflection lenses. This is pretty standard. They used this in Peugeot 308 a long time ago, and it's a good solution. The high beams with Intellilux system, they claim it has 3 rows of pixel segments or something like this. This is the most interesting part. We'll take a look inside. And also the smaller mirror here is for static corner illumination. You can see 2 LEDs in there. So the lens is cracked, as you can see. So I think the best way is to cut it, because it's going to trash, so we don't care about it. I want to also check if they use a heat rubber or chemically bonding rubber. Because if it's not heat melting rubber, then fixing this lamp is impossible. Because you have to destroy the lens to get inside. So let's do a quick pokey. And the rubber is not getting soft, so they want to make as hard as possible to fix this light. So let's get some Dremel action and start cutting. I hope we will be able to take this out. Because cutting this stuff is not easy. I would say it's hard. Okay, so we got one screw, where is it? Second screw, and there are probably some hidden Let's see if Torx 20 fits. Yeah, it fits. So this plastic trim around the lenses should be held by. We also have the something that is holding, I think, at the top. I think we can use some hot air to soften the plastic and to bend out the lens. Well, I think we need more cutting. Of course, there is another screw. I have a feeling that we need to start from the top. Crunchy, crunchy. This is only a diffuser. The light pipe seems to be okay. You can test it. Yep, that's light piping. Another hidden screw. That's a lot of screws for something you're not allowed to take apart. Maybe good idea was to start with unscrewing all the screws. They used all the screws and then they made the flaps to go under the glue which holds the lens. That's a really good idea. If we cut that much, I think we can cut this last piece. So this is the acrylic light guide and the light panel. Pretty nice stuff. Here is the projector assembly. So now we can start removing screws. And take out the corner assist light. You can see its mirror and two LEDs are hidden here. I think to free the lens we need to rotate this joint 90 degrees. I don't have this Torx. I think I've got this Torx. Let me check. A bit smaller, but it fits. These two are out. You can see the loom and the cooling fan. my light died. Great. I think I will just unplug the loom. That's a lot of wires for one projector. There is a latch that we need to press. Or not? Maybe I need to. Not manually press. As always, yes. Issue. Maybe we need to lift it. It should be similar to this. This one we have to press. And this should be the same. There would be no reason for them to make different latches for different plugs. I gave up for now. Want to release the other one. This is the low beam. The low beam is more reasonable with only 5 wires. But as I said, this is pretty standard assembly, which is used in a lot of cars. The lamps are dying, but that's a long lens. I will unplug it for later. We'll try to unplug this one. That's a lot of cables. So I will charge the lamps, I mean my LED lamps for the studio lights. So I will charge studio lights and we'll take a look at all of this stuff from the lamp. Also I need to clean here. Okay, so I'm back with clean desk and we can take closer look at 3 types of lights from this headlight. So we start with the least complicated. So the first one is corner light. It's just a concave mirror with LEDs hidden here. And then, as you can see in the mirror, how the beam is formed. We'll power it up. It's just a simple plus and minus. You can see the light pattern. So it's basically illuminating the corner of the car when you turn at low speed. So let's take it apart. I will get you closer. This is just a heat sink. This is aluminum core PCB and the mirror. I think those transistors are actually ESD protection diodes. So the diodes are connected in series. I apply the voltage and they lit up. So this works just like any halogen reflector. You got the LED on the plate. And then you've got a mirror that bounces the light out. To the side. The car is like this. The reflector is this one. So it's illuminating the corner of the car. Let's clean this up. So the next one is the low beams. You can see the lenses inside. These are total internal reflection lenses. This is pretty standard assembly for this type of lights. This one can also be powered up with those pins. We set up 22 volts because we have 7 LEDs in series. And you can see the pattern. And you can see the pattern and the cutoff line. This cutoff line is not asymmetrical as it should be in Poland, but I think they are using the second projector to do the asymmetric function. That means they can change left hand drive to right hand drive with a software. So let's get closer and look inside. So inside you can see the mirror, it's flat, and this is creating cutoff line. And you can see it's a bit concave, but it has to be to output the straight line. But it doesn't have any asymmetrical features. And here is the lens assembly with diodes. As you can see, the lenses are shallow angle, very small angle. You can see this by looking at the phosphor. At slight off angle you cannot see it. Straight from the top you can see it. So let us take off the lens assembly. And here is the PCB with diodes. Also nothing special. All LEDs are in series, and there are some thermal management PTCs or something. So let's zoom out and I will show you how this works. So if you look from the side, you got the front lens and you got the mirror. Then you got the total internal reflection lenses, LEDs, and the PCB. So it works like this. LEDs shine through the lenses straight to the big lens and also to this mirror. From this mirror, this is bounced back or straight to the edge to produce the cutoff line. Then it goes out from the lens. So this way, this is more efficient than HIDs, because in HIDs you got the concave mirror, HID bulb, and here you have the cut-off shield, and when this lights up, you lose half of the light, and the rest go to the lens and out to the road. So in this configuration you have all the light from LEDs going to the road, because even the light that goes to the shield, it bounces back to the lens and illuminates before the car. If you look at this shield from the top, if you want a symmetrical pattern, you build it like this. Here are the I can't see this. Here are the lenses. And this way you will produce the straight cutoff line after it goes through the final lens. But when you do something like this and then shine through the lens, you will have this kind of cutoff line. But as I said, I think they're making this cutoff asymmetrical feature on the high beams active matrix LEDs. So let's clean this up and go to the best thing ever. This is the big one. I got a cooling fan, also a big heatsink. Everything is clean inside, so it's hermetically shut. You don't have access to this fan, so when it fails, you need to replace the whole lamp, which is not great. So let's take off the fan. It's just clipped. You can see something, but not much. So let's take off the screws. Well, that's a nice lens array. We have something. There's some light shield, probably just to cover up the electronics Let's take off the lens assembly. The big reveal. Whoa! So I guess they didn't lie when they were talking about 84 individual active elements. There are 3 rows. The middle ones are a bit closer. That's probably where you have to make the more work to not blind the person in front you. You also have 1, 2, 3, 4, 5, 6, 7 chips. These are all the same, Texas Instruments. 92, 60, 92, 662Q. And something that looks like a step-up converter or step-down converter. Why won't you focus? Damn it. We'll probably need some macro lens. And we will take a closer look at this piece of art. Okay, so I think this is in focus now. So let's see what are the features of this TPS 92662Q. High brightness LED matrix manager for automotive headlight system. So this chip is basically for this application. 12 integrated bypass switches, 62 volts maximum switch to ground, compatible with CAN physical layer, this is the simplified application. So basically feed UART or CAN and you get the output to LEDs. So you basically feed UART or CAN and you get LEDs output. There is no diagram in this file, but I would love to run this headlight from Arduino. Okay, so let's take a closer look at the board. So here you can count the LEDs if you want. Also you can see the chips and how they are connected to LEDs. The chips are addressable, so they are on the same bus. I don't know why they need so many connections in the plug. But from the loom I can see one twisted wire for communication and the rest is straight. So maybe a power supply which is shared through many pins. So for this video, I think that's all. I will make some more research about this module and try to run it. And of course I will share it with you. I almost forgot. I wanted to shine some light through this lens assembly. I've got the flashlight, but it got the lens. So the output won't be the same as from bare LED. but we can see what is going on. I can always, also you can see they got this metal shield to block the light leakage. Nice. So let's put this together, more or less, probably less. And let's see what can we see. You can see the light is traveling through the pixels from left to right. This could be interesting. Okay, bye.